So this is the talk on making your application real-time with PubSubHubbub. We call it Hubbub for short often. So if you ever hear us referring to it, that's what we're talking about. We also sometimes call it Push for short, or PSHB, depending on who you ask. So my name is Brett Slatkin. I'm a software engineer on the Google App Engine team. PubSubHubbub is something that me and Brad Fitzpatrick, who's also here, came up with, along with some other people in the community like Martin Atkins from 6 Apart. And we've been working on a lot with the community to improve it, build it out, incorporate feedback, and so on. So today we're going to be talking about a number of things. To start off, if you want to look at notes or know how to tweet about this, the hashtag, there's a live wave, there's some moderator questions that you can load up and all that kind of stuff. There's also my site if you want to follow me. It's all right here, so tinyurl.com/push-io 2010. Okay, so the agenda. So we're going to have a little intro. We're going to talk about, are they okay? We're going to talk about publishing. We're going to talk about subscribing. We're going to talk about what hubs are, how they work, what they're for. We have a special guest, Julian Genestu from Superfeedr, who's going to talk about Superfeedr and what Superfeedr does and how that hooks into all this. Then we're going to talk about some progress and adoption and future work and improvement and things that kind of are going on right now. So intro, what is PubSubHubbub? So PubSubHubbub is a simple topic-based publish and subscribe protocol. It turns Atom and RSS feeds into real-time streams. That's what it does. But it's a single API for web scale and low latency messaging. So the idea here is that we're making it very easy for developers to add real-time capabilities to their applications online, their web apps. And in PubSubHubbub, there are 3 participants. There's a publisher who's publishing a feed of content or information. There's a subscriber who wants to get that information. And then there's this hub in the middle. And the hub is a logical component. But the idea, and we'll get into some of the philosophical things, but the hub is a facilitator of this relationship. It tries to make it as easy as possible for publishers and subscribers to work together. So some design goals. First of all, we want it to be decentralized. Some of the things that existed in the past, like Ping-O-Matic, were actually kind of centralized systems. People have talked about feed mesh and some other ping technologies in the past. But a lot of them had many points of failure, or single points of failure, and weren't decentralized, were in control of one company. So first of all, we want it to be an open spec that anyone can implement, have a lot of different pieces working together. Which is kind of what the web was built on, right? The other thing is we wanted to scale to the size of the whole web. So the web is built with decentralized protocols that scale up and can work at massive scale. We wanted PubSubHubbub to work the same way. We wanted to make publishing and subscribing as easy as possible so that it would be very easy for you to get started with the protocol, start adopting it, and start using it in your applications immediately. And part of the reason we did that is because we knew we wanted a critical mass of people to use this so that it would catch on. And I'm happy to say that we're starting to get there, which is great. We'll talk more about that later. But in order to do that, in order to make it easy for publishers and subscribers, we decided to push any complexity towards the hub. So anytime we can make it easier for publishers or subscribers in their job to build their applications, we decided to kind of push things back up into this agent called the hub, which facilitates this relationship. And by doing that, we make it extremely easy for publishers and subscribers to use the protocol. The other thing is, and for all the XMPP folks in the room, XMPP, we understand it. Brad's written a server in it. It's something that a lot of people like and use, and Google embraces in a lot of ways. But for whatever reason, it hasn't necessarily caught on in the way that everybody wants it to for publish and subscribe at web scale. And so with PubSubHubbub, what we've been trying to do is solve kind of taking a pragmatic approach to this and solve the real problems that developers are having every day. So there's a lot of things that in PubSubHubbub that are a little crufty or maybe don't have the best usage of verbs and stuff like that. And the reason is that it's pragmatic. So it's not necessarily ideologically pure like a lot of XMPP is, where it's perfectly balanced and well thought out. But the reason is that we wanted to make it easy to implement the libraries, have the libraries work with transparent proxies, and so on and so forth. All these practical considerations that kind of override the ideological ones. And we also wanted to leave out we wanted to leave some things on the table. So a lot of specs, there'll be a one-pager, and then a few people will have, there'll be a one-pager that handles 50% of the use cases. And then there'll be a two-pager that handles 75%, and then a three-pager that handles 80%. And you get these diminishing returns. So another part of PubSubHubbub, what we were trying to accomplish was, basically hit the solve known use cases that everybody has right now, and kind of not do some things specifically so that we could just get this protocol started and get people using it. So let's do a demo, see if this works. So here's all right, here's a whole bunch of apps. Let me just click around. So this is, in the upper right is FriendFeed. On the upper left is Google Reader. In the middle here is Blogger. Lower left is Buzz. Lower right is ClickSet. And I have a blog here that's connected to my Buzz profile. And it's also connected to all these other feed pieces. And so I'm going to post a feed. Now, Blogger's Hubbub enabled, and so are these other hosts. So when I click Post, depending on how much time we've got, hey there, everyone. You see that? Showed up. There it is. Let's see if it showed up in Brett's test blog, too. And it's probably here, but it's not reloading because they got a lot of traffic right now. Hey, OK. So you already see that it's really quick from publish to receive. Right? We're trying to do real-time web technologies, low latency, massive distribution, and we already have it in a bunch of products from a bunch of different vendors here, publishing and subscribing. I'm using Blogger in this case, but you could be using LiveJournal, you could be using WordPress, you could be using TypePad. So we've got a lot of people allowing you to publish and subscribe. All right, let me continue. So a big question that we get is, why another protocol? Why another publish and subscribe protocol? And almost every company out there has their own system for doing this, and there's a lot of really good ones out there. But a lot of the time, those internal systems for message queuing are just kind of much more than you actually need on the web. What we found is that what people need on the web is basic topic-based messaging. They don't necessarily need the level of content filtering in terms of the robustness that it needs just yet. They don't even realize what they need. So it's hard to convince people of all these extra features when you can't even get them on board with any kind of PubSub integration. So we were trying to bridge the islands, basically. Take every company who's got an internal MQ system and say, well, I know you're generating events and I'm generating events, but we use different systems for our own business needs. How can we connect them together in a way that's useful? And if you look at a lot of these, they either have a proprietary messaging payload, or they have a standard that doesn't necessarily, like a standard wire format that doesn't use HTTP or can't be load balanced, have different network topology needs. So there's a bunch of issues with these systems that prevents them from being massively integrated without a lot of effort. So people have tried to standardize on more simple topic-based messaging systems and other standards like that. And so XMPP is one of them, and ZEP60, which is XMPP PubSub, is a great example of a spec that really tried hard to solve this PubSub need. But it's really not used for interop beyond IM that widely. Now, the One Social Web project that came out of Vodafone Research is trying to change that, trying to do something new and different, and I definitely think it's a good thing for you to check out and look at some of the ideas there. Maybe they'll be able to get more traction with what they're doing. But in the end, these attempts at a standard for doing messaging are kind of overkill, and they haven't been able to catch on. And I could go through the list, but there's a reason for almost each one, of why it's too much. So I'll just quickly say ZEP60 does a lot of stuff that a lot of people don't need because they don't realize that they need it yet. Or the WS star stuff is too XML heavy, and people don't necessarily want to do that. They just want a RESTful interface. AMQP has a different wire protocol. You can't load balance it in the same way. REST-MS has been fluctuating a lot, so it actually hasn't been defined as a spec yet. And the REST star stuff, dictates URL parameters so that or URL paths so that I can't decide how I want my URLs to look. So we try to just avoid all of those issues as much as we can. OK, so quickly, how do you do it? So if you have a feed, an Atom feed, an RSS feed, and you want to make that feed real time, you add a declaration to your feed with a hub of your choice, or hubs of your choice. So that could be the reference hub, which I have here, or it could be Superfeedr. And Julian will tell you more about that later. Then you publish something to your feed. So it's in the document. And then you send a ping with the feed URL to your hubs, one or more. You can use as many as you want. And it's just a simple web form URL encoded payload, just like your browser would send. And you say hub mode is publish, and hub URL, this is my feed. So this is what I've updated. If you get back a 204, no content, that means that the ping was received. If you get back a 400, that means you did something wrong. If you get back a 500, that means the server is hurting or something. It did something wrong. That's it. That's what we're talking about, trying to make it as easy as possible for publishers. This is so easy you can do it from a bookmarklet. It's like ridiculously easy. Some best practices, we'll get to this more for later, but you actually can, as a publisher, do server-side filtering. Just do it with either a virtual feed ID or some kind of like a topic URL that encodes some extra information. So here, if I have my stuff app on example.com and I want to find things in zip code here, the conference center, that's a valid PubSubHubbub topic, right? So you could subscribe to that. So it's not content filtering as much as it is topic-based subscription, right? So there's a lot of things you can encode in the URL. You have to deal with normalization, some other stuff, but that's a best practice for you if you're building out some really cool real-time feeds for your site. Similarly, you can use URLs for authorization. I'll get into this more later, but by using one-time tokens and other kinds of crypto parameters, you can make those URLs actually private to an individual, so that if someone wants to syndicate published updates to only the one user, you can give them a URL that only works for them, and then Google Reader will only let them read their own items, right? OK, so subscribers. So let's say you want to get the updates. You know there's a whole bunch of feeds out there, and you want to be able to get the data. So somehow you detect that there's a hub declaration in the feed. So if I go back, you see I added this link, rel equals hub, href equals the hub address. I put that in my Atom or RSS document at the top level, feed level, or channel level element. And that declares where the hubs are located. So supposedly you've come across this feed, the user's inserted the URL, or you've done some kind of auto discovery, you've done some crawling, whatever. You found that there's a feed you want to subscribe to. And in that feed, you see that there's a hub link. So you're like, great. This has PubSubHubbub. So I will send a subscribe request to the feed's hubs, one or more. And you could use multiple in the case of reliability. In this case, you say post to it again, form URL encoded like a browser. So these are really simple kind of webhook callback or webhook calls. Again, you set the mode to subscribe. In this case, you have a verify parameter, which says if you want to do synchronous or asynchronous. You say the topic feed that you want to subscribe to, and then the callback URL. So when an event happens on this feed, where do you call back? The hub will send a request to that callback URL with a little challenge string and a couple other things to verify that you are you. And all you have to do is echo back the random string. And that's just how we guarantee, that's how we authorize the callback. And you give it 200. Now, once you do that, the subscription's set up. And every time that feed updates and the publisher pings that feed, the hub will go fetch it, figure out what's new, and then deliver a payload to your callback. That's all there is to it. So this is just a feed. I've kind of gutted it. And in a lot of cases, the hub will actually pull out old items that you've seen before. So for speed, you can actually have a differential protocol, so you only get new items or changed items. So let's talk about this magical hub that seems to make this so easy. So the hub has a few functions. It accepts and verifies subscriptions, like I just described. It receives pings from the publishers and retrieves new content. That was the how-to for publishers. It extracts new and updated items from the feed, or sends the whole feed, depending on how it's implemented. And then it sends all the subscribers the new content, so it does the fan out, right? It also has some DOS protections built into it to make sure that subscribers don't get overwhelmed and publishers don't get DOSed and all that kind of thing. It's also a logical component. So publishers can be their own hub. You can combine hubs and publishers together to have like a peer-to-peer speed up. You can also have different agreements between hubs and publishers so that if you want to publish on Thrift or through JSON, if that's better for your infrastructure, you could do that. That's outside of the boundary of the spec. So the relationship between a publisher and a hub is actually totally up in the air. It's not a specific requirement of the protocol. The pinging that we've implemented as part of the base spec was to bootstrap the protocol so that people could start using it immediately, so that you could ping from a bookmarklet, for instance. But the hub is what's able to facilitate this relationship, provide scalability and reliability of delivering these messages and scaling them out. OK, so now I'm going to hand it over to Julian Genestou, who's the main guy, the superhero at Superfeedr. So, Julian.
Hi. Good to meet you. So basically, we're Superfeedr, and we're a shop that helps make PubSubHubbub be something that is more than just something at Google. And let me get into a little bit more detail. For this, we provide a few stuff. We provide what we call first the default hub. It's a hub that works with basically any feed. As Brett just showed us, PubSubHubbub is a protocol that needs to be declared in a feed. The Superfeedr hubs works with any feed. So if you're a subscriber, you could say, hey, I want this content, please push it to me. We will do stuff to get that to you. The second thing we do is hosted hubs. So we provide pretty much the same thing as Google provides for people who don't want to use the Google Hub for whatever reason that they might have. The last thing we do is what we call PubSubHubbub plus benefits. So as Brett just showed us, the bare protocol is pretty easy and simple. And we just add a few layers on top of this, and I'm going to come back to that later, to make it better, nicer, smarter, whatever you call it. So let's start with the default hub. So this is actually the historical Superfeedr. Superfeedr started last year, pretty much at the same time. And we were basically doing feed polling on behalf of other people. So say you are a big service that needs to aggregate a lot of content from the web. Instead of doing that yourself, you would give us the URL, and we would do that for you. The goal is to, as much as we can, avoid polling, though. For that, we use different techniques, like smart scheduling. So we try to determine when is the best time to fetch a feed based on historical values, historical updates, based on what we call feed graphs. So for example, if you have a FriendFeed account and a Twitter account, when we see an update in your Twitter stream, we might assume that the FriendFeed is going to be updated and that you have linked the two together. So we do all this graphing to know basically how updates propagate. We also do stuff like protocol mapping. Last summer, there was a big fight between PubSubHubbub and RSS Cloud. I think it's pretty much over now, but we basically implemented the two because we thought that subscribers shouldn't choose, or at least shouldn't have to implement all of them or choose to implement just a few of them. By implementing one, we would basically map that to any feed. So we implemented RSS Cloud, SUP, which is a protocol that was made by FriendFeed, XML RPC, a few other stuff. We do push to the subscriber, pretty much exactly what Brett described. And we also do XMPP, which Brett just trashed, but it's great. But it's actually great protocol. It has definitely some pretty steep learning curve, I would say. But once you get it, it's pretty powerful. And we do a last thing, which is the schema mapping. In a nutshell, as a subscriber, you shouldn't have to care about whether the original feed is Atom, RSS, RSS 0.92 or whatever, or even if it's not valid. We just do the hard work for you of mapping everything into the same consistent format. So your application just have to consume that and do whatever it is that you do best. So basically, that's the point here, is focus on what you do best, and we'll do the rest. A few use cases of people who actually use the default hub. There's a bunch of iPhone apps that can send you notification while you're at a conference, for example. We help them get content from feeds. So Urbanership is an example. Boxcar is another example. There are obviously feed readers. You guys probably know WebWag or Feedingo, which are out there, pretty nice application. We have desktop notification. So your desktop application would subscribe to Superfeedr to get updates and then ping you on the desktop. Adobe made a product called Wave last year that does this. We also have a few semantic search customer where basically they need to have a lot of data. Rather than spending time gathering it, we just do that for them, push it to them, and then they do their magic. Guzzle.it and Twingly are a good example. And then there is also social web, social apps that might want to aggregate all your data from X social services, might not just want to subscribe to all of the feeds and will just give us the URL and we'll fetch that for them on their behalf. The second thing we do is hosted hubs. The idea is like, if you're a publisher, you shouldn't have to reinvent the wheel, nor that you should have to run the wheel yourself. You just can use somebody who does that for you. And that's pretty much what we do. So if you're a publisher and you have feeds, rather than implementing the protocol or use, or should I say, download and install your own version of some open source code, just give us like the pings and we'll care about the rest. It's on the other hand, we think since it's your hub, it needs to be your data. So we have like full export of the data at any time, etc. So it's really like running your own without any hassle and any maintenance or any debugging that you would have to do. We provide a few cherries on the cake, like analytics, callbacks, meaning like you might, as a publisher, you might say, hey, PubSubHubbub is great, but I don't want to allow spammers to get my content as soon as I publish it. It doesn't make sense. So I want to make their life not as easy as PubSubHubbub make it. So I want to know, upon subscription, who is subscribing to what, and this is what we actually implemented. A few reference for hubs that we host, Posters, Tumblr in the blogging field, social networks like GoWalla, Ping.fm, media, Gawker, Huffington Post, and there are a lot more to come. Coming back to the schema mapping, this is one of the things that we do and that I think is very important. Obviously there is, as I said, a ton of different formats, and as a subscriber, you might not want to deal with pub date in RSS for the published date and published in Atom, or even updated sometime in Atom, or even like pub bait because there is a typo in the feed. We will do that for you. The other thing is like there's a ton of different namespaces out there, and some of them are very redundant. The Dig, the Mix, and the Yahoo Buzz have their own namespace, which is basic. While the information, the semantic is the same. It's voting on a story and the number of votes. Why would you have to have 6 different namespaces as a subscriber and implement all of them? So we just make sure that it's always easy for you to consume the data. We obviously care about the ton of invalid stuff, and there's pretty good stories about this, but basically missing tags, wrong dates in other calendars, like we've got Arabic dates and we need to tell you, hey, this happened in 13th century. This is actually not the case, so we need to figure that out. Unique IDs that are not unique. We've seen pretty much a lot of publishers putting timestamps in unique IDs, which kind of kills the purpose. We also do stuff like geo-RSS, so we can push you the data and tell you, hey, this is basically the geo coordinates of where it happened. And we also do, for the social web, activity streams. So as a consuming application, you know the verb, the activity, the verb and the object that are concerned by a specific activity. We, on top of PubSubHubbub, also provide a few extensions. One of them that we just launched last week is what we call digest notification. So the problem with most of PubSub protocol is like they fail silently. If I tell you, hey, wait here, I'm going to tell you when there is something new, and then I just go on vacation for like 2 weeks, you're going to wait because you assume that I'm going to tell you, while no matter what, I'm gone. So you can wait for a long time. It won't happen. So we implemented what we call digest notification, which serves 2 purposes. Heartbeat, so we can tell you, hey, no matter what, you're going to get an update every 24 hours. And digest, so that if by any chance you missed anything during the day, you know what's happened, what has happened, and you can actually catch up. We also implement a few other stuff like feed status, so you can query Superfeedr to know what is the current content of a feed. So it's much easier for you if you have been on vacation for 2 weeks to come back and say, hey, what did I miss? We have subscription callback that I just mentioned, where you can, as a publisher, decide whether you want to allow subscription or not from a specific user. And the last thing we are implementing is called virtual feeds. So let's assume a small use case where you would subscribe to a feed from, I don't know, Craigslist, on the San Francisco car search, and you might say, hey, I just don't want San Francisco. I also want San Mateo and I don't know, some other town in the area, Oakland. We would do basically a virtual feed that combines the information from the three, so that as a subscriber, you don't have to subscribe like 3 times to 3 different sources. In terms of the Superfeedr infrastructure, we're basically a big botnet. This is independent components, little XMPP workers, we love XMPP, that connects, say, hey, give me work, and then some other distribute the work to them, and they do what they have to do, and then at some point they die, like everybody here. The good thing about this is like, we're like, if something is wrong, it's never wrong longer than the lifetime of one single worker, so it's not that bad. For the polling, we have an interesting thing, which is a massive ring. So the polling, it has to be scheduled. So at any time, we know, hey, we need to fetch this feed now, this one in 10 minutes, and this one in like half an hour. So we've built this infrastructure, which is a huge ring. So basically, we take an item in the ring and then put it in the back again. And so it makes a big loop, and we try to run this loop as fast as we can. We currently do 70,000 feeds a second. And then we have a lot of caches to make the diffs. So as Brett explained, the PubSubHubbub protocol, the hub is supposed to fetch the feed and see what is new versus what is old. And this is something that's pretty hard to do when you start having millions of feeds. And you need to be able to diff very efficiently. So we use a lot of cache mechanisms in cluster to do that. A few number of the Superfeedr infrastructure. We currently push content to about 1.8 million endpoints. That's about 20 million entries, atom entries a day. Just for the reference, Twitter in February said that they were publishing about 50 million tweets a day. So it's pretty much, it's slightly smaller, but I'm pretty sure like in 3 months we're going to be bigger than them. We have about 50 hosted hubs, 45 dispatchers that send information to the subscriber, 80 parsers, and that's about 50 servers at the moment. In terms of growth, here you have the number of subscription that we've had over since January 1st. It's by week, and it's, as you can see, it's pretty much growing very, very fast. We expect to be like at 3 million before the end of June. A few to do before I leave you back with Brett. Make your feeds real time. This is really, really important. Make them real time, and we can help. So ask me. Follow Superfeedr on Twitter. Say hello to @Julian51, which is me too on Twitter. Pick stickers. I have pretty much for everybody, I think. And thank you very much.
Great, thanks a lot, Julian. Cool. So let's, that's great to see another independent company doing some really cool stuff with PubSubHubbub and helping a lot of other companies do a lot of really cool stuff with real-time feeds. And so I want to talk more about the kind of progress in the community of PubSubHubbub adoption thus far. So there's actually over 100 million feeds that are PubSubHubbub enabled. And we have companies like Superfeedr and their friends, all the different companies they've enabled, the logos that Julian was showing you. Plus Google, 6apart, LiveJournal, MySpace, Twitter Feed, NetVibes, ClickSet, GNIP, PostRank, and a bunch of other kind of companies like Radian6 are all using PubSubHubbub for kinds of scanning and all kinds of search space intelligence stuff. In terms of Google products, we have full integration with Google Buzz. That means that with Google Buzz, both your feeds going out, like the feed of your buzzes, and for connected sites that you connect to your profile, Google Buzz will actually use PubSubHubbub to receive those updates. So when I showed you my demo earlier and I posted to Blogger, the reason that got there so quickly was because Gmail is, or the Google Buzz is subscribed to my feed using PubSubHubbub. So if I had done the same thing from LiveJournal, you would have seen the same thing. Buzz, it's great, it can do in and out, and there's a bunch more stuff around the Buzz API today. We also do it for comment feeds and tag feeds, so you should check that out. We have integration with FeedBurner. So this is if you ping FeedBurner after updating your source feed, FeedBurner will fetch your source feed. It'll burn the feed as a proxy, adding whatever stats you want and advertisements or whatever else you use FeedBurner for. And then it will publish your feed using PubSubHubbub to notify subscribers. So if you're using FeedBurner, chances are you already have this enabled for your feed, and you just don't know it. And a lot of the infrastructure that you've already had to ping FeedBurner with your updates is being reused to make your feed real time. So I suggest you go check out your feed and see what's there and experiment with it. And we're making progress to make FeedBurner better at doing this, integrate better with Superfeedr, and basically allow everyone to provide better stats about subscription and publishing. Like I said, we have Blogger integration, reader shared items, so both of the published feeds there are real-time through PubSubHubbub. One that's really cool is Google Alerts. So you can sign up for a feed with Google Alerts, and you can subscribe to that feed using PubSubHubbub. That doesn't mean as soon as something is added to the Google index, it shows up on the feed, but it's actually really low latency. It can be scary low latency sometimes. So you should definitely check that out. FastFlip also, which is a news product, Google News product, will publish new updates using PubSubHubbub. And there's a bunch more stuff on the way. I wanted to give a plug really quickly. Tomorrow, I think at 1 o'clock, there's another session here at Google I/O for Brett Bavar and Moshe Letvin are having a kind of real-time Ajax APIs and App Engine API talk, and it's talking about the new Feeds API, which has real-time capabilities, and also the real-time and browser push API for App Engine. So if you're interested in how Google's making it easier for developers to add PubSubHubbub subscription to their to your applications, I definitely recommend that you go check the talk out and learn about it. Yeah, Julian had some great numbers from the Superfeedr hub. I wanted to also come out with some cool numbers from the Reference Hub. And again, the Reference Hub is an open source implementation of the PubSubHubbub protocol. It runs on App Engine. It's written in Python. It's open source. I'll show you. If you search for PubSubHubbub, it's the first link. You can find it. So it's interesting. So we're doing about 200 plus feed fetches per second. That's kind of our average peak. We're delivering 250 plus items per second. That's just items. That's not necessarily multiplied by the number of subscribers. It gets a lot larger if you do that. And we have 70 million active subscriptions. And we've delivered 1.2 billion items since July of last summer. And so that's about 50 items per second. And the traffic keeps ramping up and up and up. So if you average it out, it's 50 items per second, I think. Yeah. And then, but anyway, it's getting up there. So really happy with the uptake. Really happy that the hub and App Engine have been scaling really well. And like Julian was saying, it's interesting comparing traffic numbers of, say, like Twitter to PubSubHubbub. And both, we are working on different feed providers and different publishers. So we get to add our numbers together because we're part of a decentralized system where they don't, right? So that's pretty cool to see the decentralization and network effects kind of coming into play. So here's that site, pubsubhubbub.googlecode.com. Misspell it however you want. I promise you'll find it. Nothing else like that. We have clients for you to use immediately. So if you're publishing Perl, PHP, basically everything listed in here, including Haskell for all you guys. You know who you are. We've got it for you. There's subscriber clients for PHP, .NET, Scala, and Zen Framework, and a whole bunch of other things. I think some of the coolest ones I've seen, I think the Drupal module is really good. If you're doing anything with PHP or Drupal, there's a feeds module by Alex Barth that's really awesome. It does basically everything you could want to do on the subscriber side. It can also deal with PubSubHubbub notifications and works very well with Superfeedr. So I would definitely check that out. There are hubs. There's the App Engine Reference One, both hosted and not. There's Superfeedr. I'm talking about source code here. That's why Superfeedr is not in this list. WordPress has an open source implementation of a hub that they run for their hosted blogs and for blogs that you host yourself. There's one written in Erlang that actually will bridge. So it's part of. It's actually works on top of RabbitMQ. So it's called Rabbit Hub. It's written in Erlang, and it'll actually bridge from RabbitMQ, anything RabbitMQ will connect to, into PubSubHubbub and back again. So they've got all kinds of crazy transports. They'll even transport to SMTP if you want them to. So definitely check that out. We've got a mailing list with 440 members or more. A lot of members of the community, a lot of discussion there about new ideas and problems and so on. So I invite you to come and join and bring your questions and participate. And like Julian was saying, there are more publishers on the way, more subscribers, and more hubs coming, which is great. So that's kind of the beginning part of it, kind of the state of the union, everything's happened and what's going on and adoption and so on. I wanted to talk a little bit about kind of the future work and where we're going with this. We've got a lot of traction and momentum built up, and we're hoping to keep it going. So I wanted to talk about kind of what the next steps are and what we have in progress. So the big one that we keep hearing from people is arbitrary content support. So arbitrary content type support. So I don't know if you saw Facebook's real-time API that just came out at their Fate conference, or F8, but it used about half of the PubSubHubbub protocol for doing real-time notifications, which is great. It uses webhooks, it uses the same verification protocol, but they needed a different payload type, and they needed authentication, and among a couple other smaller things. And this is something that Brad and I have been talking about and working on for a long time, is figuring out exactly how we wanted to do it. And what we wanted to do to start off was just do feeds extremely well. And we're getting there, and we're starting to do that well enough that it's getting a critical mass. So now we're ready to kind of move on to the next pieces of this. So I'll give you some use cases. The microformats people, they're interesting guys, and they say, why would you ever have semantic data? Why, like, they don't believe in RDF, they don't believe in XML, they don't believe in things that parse correctly, which I think is actually, make it human readable first, and then machine readable, second. I think it's an interesting approach, and it definitely works really well. I don't know if you've seen any integration of microformats into Google search results, like recipes and dates, hcontact or hcards, but it's actually really cool what microformats does. So they've got something called hatom, where they want to take an HTML document, mark it up with some semantic tags that say, well, this is actually an Atom feed, even though it looks like an HTML doc. And this is post number 1 with this ID, and this is post number 2 with this ID. So they can overlay an HTML document from presentation with a feed and make it so that it has both a human presentation and semantic meaning. So they'd like to use PubSubHubbub for their delivery, because they want the real-time things that are great with the microformats that they love so much. So they want HTML push. Google, we really care a lot about indexing. So does Microsoft with Bing, and so does Yandex with their search engine. And so, sitemaps are a way that the whole kind of search and indexing industry, finds out about new content, and especially for breadth. And so, we would like to be able to push updates for XML sitemaps, so that when you update your site and your sitemaps, and you have some very deep pieces of content that get updated that don't get crawled very often, you can ping and say, my sitemap is updated, and all the crawlers of the world will know that and then go and fetch the latest content. But they need to get the whole sitemap with all the different URLs and whatnot and understand that they need to fetch it. So Google wants to be able to do XML pushing for that. And then JSON is the Facebook case. They'd like to push some JSON data through there. A lot of the activity streams people also want to be able to push JSON for the activity streams representation in JSON. And that also is easier for developers to use in a lot of cases. So our plan is to build on some of the LRDD or LARD, or however you want to say it, web linking stuff. If you just search for LRDD, there's a nice document. It basically says how to use a link header in an HTTP response to indicate where the hub is. So that means that if you're serving, say, a JPEG image, and you want to, maybe it's your avatar, and you want people to be able to subscribe to updates to your avatar, how would they do that? Well, they'd go and fetch your avatar, and on the response, they'd see a link, rel equals hub, hub equals blah, blah, blah. So it would be the same kind of semantics like we saw in the feed, but for any HTTP resource, right? And then you'd be able to subscribe to that resource on that hub, and anytime it's updated, you'll be notified with the full payload of the updated data. So that's what we're planning on building on. We're working on building out the hub and figuring out the protocols. We've got a lot of really good feedback from the people at Facebook about what they want in this regard, and it's awesome. I mean, this is what community and peer review is all about. So that's really cool to see. The other thing that we're working on is private feeds. So this is a common misconception that people have about PubSubHubbub, is that it only works for public feeds. Well, that's certainly what we've been trying to get adoption on, because that's most of what's out there. But you actually can use PubSubHubbub with private feeds if you know the right approach. And so our plan is to basically achieve all of these goals. We want it to be fully encrypted, we want authorization of the subscriber, and we want it to be authenticated bidirectionally. We want to integrate with some of the other tools out there for auth, like OAuth, RelMeAuth, and WebFinger. And then we want people to be able to use the same technology for both private feeds and for other means. So for instance, if you want to apply business policies like say, okay, I want to authenticate my subscriber so that I know that they don't subscribe to more than 100 different things. You know, that's how maybe you could enforce your business model if you wanted to. So you should be able to do that. And Superfeedr kind of does this with an extension that they've built where they say, well, you know, the subscriber has to authenticate because I want to make sure that spammers don't get my content. It's like understandable, and authentication or private feeds are one way to achieve that. The other big thing is that we want to be able to achieve per item privacy control. Now, one of the first things that people come up with when they say, how are we going to do private content in Atom feeds or PubSubHubbub? They say, well, okay, what if we just didn't actually put the content in there, but we put like a little marker that said there was content? Like there's something private here, and here's the timestamp and the ID. Go fetch it over here with your authentication header, and we'll give you access. Well, I mean, that's definitely an engineer's solution to the problem. But it has a bunch of problems. The biggest problem it has is this idea of plausible deniability. Now, I'm not planning on stealing anything from the 7-Eleven down the street, but you know, if I checked in at 7-Eleven, let's say, and you know, using Foursquare or Gowalla, even if that content were private, it puts me in a location, or at least the fact that the event happened causes me to be associated with a time and place. So if it's 3 in the morning and I check in with Gowalla or some other location-based service, and that's just the fact that it's communicated that the event came through at 3 a.m. ties me to a time and place. And I'm not saying that people are going to be you know, committing any crimes or anything like that, but I think it's extremely important to, when you're talking about privacy, you really need to respect privacy, and you need to be able to enforce plausible deniability. That is the litmus test in my mind. So the solution to private feeds that we're working towards is also being able to enforce plausible deniability, so that the feed, if you don't have access to the item, you don't even know the item exists. So the simple way that we're kind of going at this is we're saying that each subscriber will actually have a unique URL that they subscribe to, so that on the hub side, the hub will understand the actual authentication that is available. So what I mean is, if both me and Julian have access to the same items, then the hub will send us both the same items. But the hub understands who we are and what our ACLs are, okay? So that if an item comes in from the publisher that only Julian has access to and I don't have access to, then the hub knows to only send it to him and not send it to me. So in the same sense that original philosophy of PubSubHubbub was to say, put the complexity in the center, put it in the hub, so the hub understands the really difficult parts, we're going to do that again. We're going to say the hub has to understand the ACLs of the feeds that are subscribed to and the equivalence between those feeds, and then fan it out per item to the subscribers as need be. So we're getting more into the scaling issues here, the actual design. We think we can make this scale properly, and that's part of why it's been taking so long, is making sure that we kind of take a rigorous look at the design to make sure it'll scale. But the hope is that we'll be able to have fully authenticated feeds, so that the idea of having Google Buzz get location data from Gowalla and have it be fully authenticated and private without any kind of ACL issues, that we can actually have that decentralized future. So that's what we're working towards. It's a big thing. So if you're interested in that, please join the mailing list and talk to us. So some further reading. So O status is something that's really cool. If you've done any of the other social track stuff today, you've kind of heard about the pieces that are in O status: Salmon, Webfinger, PubSubHubbub, and activity streams, and portable contacts. O status is an interesting approach to this from the status.net and Identica guys. It's definitely worth a read just because it's a very interesting investigation into building decentralized protocols. The Buzz API you should definitely check out. Kind of the vision for the Buzz API is that Buzz is just one island amongst many, and those islands are able to talk together. So we are working on, at Google, decentralized social networks that can actually speak with each other. So that's a really cool point of reference. And the Facebook real-time API, you should definitely check out what they're doing there. It's a very clean API. Their use cases are very understandable. And so it's definitely worth checking out and seeing some, comparing and contrasting their needs versus the spec as is, and kind of seeing, where things are going to go. Right, so you can view live notes and ask questions on this wave. That's where I am. Superfeedr and Julian are at superfeedr.com. We're going to open the floor to questions, and I'm going to click this button. I don't know what's going to happen. Actually, I'm going to go over here because it's probably not going to be good. So Let's see. So yeah, if there are any questions, there's a mic right here. If you have any questions for me or Julian, if you'd like to run away, it's okay. Go ahead. It's the last session. So, all right. So, okay. Well, all right. This first question here is, Brett, what kind of volume are you seeing in the reference hub? Hopefully I answered that. So, a lot. Another one is, do the subscriber or publisher need to renew the subscription periodically, or does it keep going forever? So part of the PubSubHubbub protocol is something called automatic or periodic refreshing. So it's actually on the hub to notify the subscriber of how long their subscription will last, and then also to refresh that subscription for the subscriber before that period. And basically, the hub can refresh the subscription whenever they want, just to make sure that you're still there. If you have a lot of drops, they want to make sure you're still there. So the subscriber doesn't need to periodically double check its subscription. And there are things like what Julian's doing is extensions that Superfeedr has for digest and heartbeat for people who are extremely paranoid about missing an update. And these are interesting things that we might look to incorporate into the protocol or as an extension to the protocol going forward, because it is a common concern. But in the base protocol right now, you should be able to trust the hub, that the hub is delivering that content on behalf of the publisher, and that the publisher trusts that hub to do that. So you shouldn't have to do that. Yep, question.
Hi, Jorge Ortiz, UC Berkeley. I was wondering if there were message time delivery constraints, since you say it's real time. Would I be guaranteed that I'm not going to get a message, a day late, or what's the variability in that?
So you're talking about at the protocol level, or are you talking about just
at the protocol level, yeah.
No.
Okay.
There's nothing, and I think that part of what we're doing is with the reference implementation is just doing the best we can.
Yeah.
And we have an open hub because we're just trying to boost adoption as much as possible. But Julian, do you have a?
Yeah, we basically have the same. Like we don't have for the ping thing, we don't have a guaranteed delay. For the polling, so for the default hub, we can guarantee 15 minutes. So if we have no way to know if there's anything new, we're going to poll every 15 minutes. But for the hosted hub, for the core protocol, no, we can't guarantee anything yet. I hope we can soon.
Have you done any measurements to see what the message variability is, or is that not a concern right now?
So we have a series of probes that we run on the reference hub all the time to see what the latency is. Mm-hmm. And I don't have that graph here, but we try to shoot for a window, and we have spikes here and there of up to a minute, but usually we stay underneath 10 seconds at all times.
Oh, okay.
But there's some variability in there, but it's pretty consistent. I think though that there's also drops, and we're not measuring drops as accurately. So full drops are also an important metric that we want to get out there. But I think that this is all developing, and as people go along to realize that this is core infrastructure they can build on, that will make reliability and retries even more of a stronger guarantee. So for instance, if you had a Google Doc that every time it updated, you wanted an update through some PubSubHubbub notification, you want to guarantee that that's going to get there. Mm-hmm. So at that point, there's actually a business need and a requirement, and you're saying, I'm a developer, I'm going to bet on this. And so then we'd have to actually provide at least some kind of SLA, like hopefully an SLA eventually, but also just a guarantee saying, like, hey, if you don't get this, like, it's our bad.
Right, so that was sort of what I was getting at, was whether there was an SLA description or anything like that.
Yeah, it's still way too early for that, but I think that obviously that's what we'd really love to get there. If it was so important that people wanted an SLA, that's awesome.
Great.
Yeah.
Thanks.
Yep.
Yeah. I'm wondering which browsers support the push.
You should go to the talk tomorrow. And like I said, that's not actually part of the PubSubHubbub protocol. That's a tool that Google is providing to people. My understanding is that it's all browsers, and I think including IE6, maybe? Yeah, IE6 for you. We've got it.
You mentioned this could be an alternative to XMPP, right? So one of the main things that XMPP provides is presence. So how does this support it?
Yeah, that's a really good question, and I think that it doesn't provide presence, right? And that's why this is not solving the same problems that XMPP are. XMPP is really good at solving the last mile problem, and presence. That's why Google uses it for stuff like Google Talk and for Wave. So when you really need, yeah, we could have a feed of your presence. We definitely could do that, but
Yeah.
like that wasn't the initial point. We were trying to do server-to-server integration, right? So like XMPP is really good at holding up in a single connection, like down to a mobile phone, and then doing presence notifications. But I mean, I would love to see someone try, build a feed of presence notifications if you could. But XMPP is really good at that right now, and
I think Brad's point is great. Like we think that a lot of, PubSubHubbub is very simple, and since you use feed, you can actually represent so many different information with feeds that you can do presence with feeds over PubSubHubbub. Like, obviously, like I'm online, I'm offline. It's a row feed, right? So you can definitely make some kind of presence-like information via PubSubHubbub.
Yeah.
Another use case that we've seen recently is sync between two services. So you just mentioned Google Doc. So say I have Google Doc on one side and Dropbox on the other side. It would be awesome that every time I update my Google Doc, it just saves to Dropbox, and every time I put a file into Dropbox, it just uploaded to Google Doc as well. And this can be done very easily with PubSubHubbub. Actually, the only requirement is like both services need feeds, and they just subscribe to each other, and then you can have sync data across as many services as you want.
yeah, and all the stuff like idempotence and deduping and update time and all that stuff is figured out by Atom and the Atom format. So you get all the goodness of kind of Atom. And you can even apply stuff like the feed sync protocol that Microsoft developed on top of that for even more robust synchronization mechanisms.
One more thing. So is the reference implementation is something that we can use internally rather than as a hosted model?
Internally only, right, behind the firewall?
Yes.
Yeah, so I guess talk to Julian, and those open source hubs you see out there, you could run those behind the firewall for locally addressable feeds also, if that was something you're interested in. So I think that answers your question, maybe. So, yeah.
Right.
Yes?
I'm wondering if the protocol says something about a publisher gone rogue, like sending like too many updates. How to handle that? Any recommendations?
Yeah. There's a thread on this on the public list, I think just yesterday, and so if the publisher starts sending like 1,000 pings a second and the hub doesn't know what to do with them, how do you prevent the publisher from DOSing the hub? So first of all, hopefully the publisher and the hub have a decent relationship with each other. That's kind of the assumption, because the publisher is trusting the hub to deliver their content. So the incentives aren't necessarily there for a publisher to DOS their own hub, right? But let's say you did that anyway. I think it's an important best practice of just having a website to have DOS protection. And this is in no way different. So part of the reference hub has a DOS protection element where it'll actually do counting of IPs and requests over a kind of leaky bucket kind of thing to make sure that there aren't too many pings and that slow feeds don't have a negative effect on the hub's health. So I think that that's just a general strategy anyone can use. It's not codified in the protocol, but it is kind of in HTTP. Like if you get a 503 back off, then you should back off, or else you're going to get black holed. So I think that, I don't necessarily think we have to add it to the protocol, but it could be something in the best practices to say like, don't, if you're a publisher or if you're a hub, implement DOS protections to make sure that you don't get screwed.
So basically, the publisher will find out that through 503 or whatever that they have been.
Yeah, that they need to rate limit themselves, basically. Yeah, 503 retry after. That's that's what the reference hub does right now. The more interesting case that I've seen is the subscribers just oversubscribing. Subscribers subscribing at 100 requests per second. This is happening right now on the reference hub, and they get 503s all day long, and it doesn't hurt anybody except for my bandwidth bill, which I don't pay, so it's okay. So, yeah.
Similar question. So how do you prevent me setting a callback that is a ping URL for another hub that's decentralized, and then setting a callback on the other hub that's a ping URL for your hub, which would create like a cyclical.
So
but
generally,
it's decentralized, so you don't have any common.
Generally, the hub doesn't trust the publisher, so it's a light ping. So whenever a hub gets a ping, it will just fetch the feed and see if there is anything new actually, and then you can take measures if you trying to ping me for content that is not there, might want to blacklist you or whatever, but the hub doesn't trust the publisher yet.
Right, and that's one of the core design goals we had when designing the protocol was not requiring authentication between the hub and the publisher. you just send a light ping, and it's like, if you actually serve that feed, then I will go to you, I will use SSL to authenticate, verify the cert on, and then that's my authentication. I don't need to authenticate the pinger. But you can get some efficiencies out of fat pinging, but that's not defined as part of the protocol. It's up to you how you want to integrate with your hub to do that. We do something internally for that. Other people might want to do something else, and so we're just kind of leaving that undefined so that people can just do what they want.
For some hubs that we host, we actually implemented the API of the publisher so that we actually subscribe to their content through their own API rather than just pull them and they don't ping us. But again, this is the publisher-hub relationship. This is part of the protocol, but I think this is probably something that is kind of on the margin, not that much of key and all the time.
Yeah. I think we got time for one more, but I don't see any, and I don't see anything here. So all right, well, thanks a lot for coming. If you have any more questions, we'll be here.